Good morning, students. Yeah, good morning, everyone. I think this is the first class for us in online. Right? So, if we come to here, yeah, previously we have discussed till what the unit vector, addition of vectors, how to find the direction, what is the angle, in coordinate system, what is the magnitude, and how to find the directional cosines there. Okay. Then, when we come to the last concept where we stopped, that one few students already asked in the previous class, how to find whether that given two vectors are parallel to each other, and how to find the vector whose magnitude is equal to one of the given vectors and direction in the direction of the other vector. Okay. Of course, I gave one question to you all that you take it as granted as homework. The same kind of problem, better we try to discuss it today. Okay. So here, if I take one vector like a bar is equals to say some 2 I cap plus j cap, plus here I am taking it as 2k cap. Okay. And the second vector I'm taking here d bar equals to like some 4 I cap plus 2 j cap plus 4 k cap. Okay. So first of all, we are going to prove that these two vectors are parallel to each other. Okay. Show that they are parallel to each other. Parallel to each other. Okay. To show that they are parallel to each other, what we have to do? First of all, we have to understand that their directions are same. Okay. If their directions are same, means first vector is taken here like in this direction. And second vector is also taken in the same direction. Then whatever may be the magnitude, but they are parallel to each other. Parallel means they are existing in the same direction. Okay. Same direction. Direction actually will be given by whom? The unit vector. That's why better you try to find out the unit vector along A bar, the unit vector along B bar. Means I am going to find out this is A cap and this is B cap. Okay. So if A cap, the direction of first vector, is equal to B cap, the direction of second vector, then no need to prove they are parallel to each other. So here I am using the concept, if here A cap is equal to B cap here, then I can conclude that they are parallel to each other. So simple. How to find A cap, you know already. Okay. How to find here A cap, that is A cap is equals to, all we know, that is A bar upon mod A bar. Oh, sorry. Mod A bar. We are coming here. A bar to mod A bar. Okay. This is A cap. So here, first of all, A bar, of course, we know. So mod A bar, we have to find out. Mod A bar means you know the method how to find root over here like ax square plus ay square plus az square. Ax square is 2 square. Ay square, all of you can calculate, that is j cap component here 1 square. Okay. Plus az square, that is 2 square. Okay. So you are getting there, that equals to root over what? 4 plus 4, 9, sorry, 8 plus 1, 9. So 4 plus 1, here I am getting plus 4. That I got equals to 3. Okay, root over. So A cap is equals to, I am going to get there A bar. Going to write here 2y cap, first one, plus the second one is J cap, and the third one is 2k cap. Okay, this is A bar upon mod A bar, that is 3. Okay, this is A cap. Then later what we have to find out? B cap. Okay, so B cap here, in the same way, if you try to find out, B cap is equals to, that is B bar upon mod B bar. Oh, sorry, B bar mod B bar, we are getting there. Okay, so here what is mod B bar? First we have to find out. Okay, mod B bar is equals to, what I am doing there, is equals to root of, as usual, first 4 square followed by, next here B bar, look at there now, like bx square plus by square plus bz square. So bx square 4 square, by square is 2 square plus bz square is 4 square. So you are getting how much? That equals to root over 4 square is 16, 2 square is 4, and again 4 square is 16. So you are getting 32 plus 4, 36. Root 36 means you are getting, that is 6. So I am going to substitute here. This is equals to B bar 4i cap plus 2j cap plus 4k cap. Okay, upon mod b bar is how much I got there? 6. Okay, so here if you take numerator and denominator in both common 2 from the equation, look at there, if I take 2 common here, what you are getting? 2 I cap here, 2 taken out, so plus j cap, and here 2 taken out, so plus 2k cap upon 6. Also you write like 2 times 3. Okay, so 2 into 3. So you are getting how much here after cancelling 2 over there? 2, 2, if you cut. Then you are getting same exact, you observe there, 2i cap plus this is j cap plus this is 2k cap upon you are getting 3. Once you check now here, what is a cap you got and finally what the b cap you got there. Okay, just I try to highlight to recognize. Once you check, this is a cap and this is b cap. Okay, check that. Both are one and the same. 2i cap plus j cap plus 2k cap upon 3, and this is 2i cap plus j cap plus 2k cap upon 3. You are getting the same. Okay, that's why here a cap, b cap both are same. If they are equal, already I said here, if they are equal, then they are parallel to each other. Okay, they are parallel to each other. Therefore, I can say a bar and b bar are parallel to each other. So henceforth, they are parallel to each other. Okay, this kind of model actually I gave as homework to you all. A cap equals to b cap. All right, okay, good. Now, if you want to ask any doubt or want to share your way, better you come to WhatsApp now. Why? Because I'm not able to see the WhatsApp, sorry, YouTube here, whatever you are chatting there. Okay, better you come to WhatsApp so that I can see your options. Okay, right, good. This is the first question what I gave the assignment to you, right? If you have any doubt, you can express in your WhatsApp group. You can take that question now if you don't have any doubt. Okay, right, good. If you don't have any doubt, you can take the question. If it is completed, I will move to next question. Okay, shall I move to next question, Nana? That is finding out one vector in the direction of another vector. What I give the second question to you all as the homework. Yes, yes, yes. Shall I move to next slide to find out that kind of model? Second question model. Okay. So going to the second question model here. Yeah, coming to the second question. Second question is what actually finding out the vector whose magnitude, okay, is equal to b bar in the direction of a bar. Whose magnitude is equal to means second question. Here I am going to write. In the above question, same question without writing the question again. In the above question, I write like this. In the above example, find a vector, say some c bar, a third vector c bar, find a vector whose magnitude, okay, whose magnitude is equal to b bar, means first you try to identify what the information given there. The magnitude of a vector is mod c bar. This is magnitude of third vector c bar, what we have to find out. He said whose magnitude is equal to b bar, means its magnitude is equal to the magnitude of b bar, that is mod b bar. So this is the information what we have identified from the given question. Find a vector c bar whose magnitude, its magnitude is mod c bar, is equal to mod b bar, equal to that of b bar, magnitude of b bar. That of b bar, okay, and it acts in what direction? And in the direction of, in the direction of whom? First vector. Who is the first vector? A bar. Direction actually decided by whom? From the previous question we identified direction will be given by cap. A cap like B cap. B cap gives the direction of B bar. A cap gives the direction of A bar. So here he is saying it's a direction. Direction means C cap. Okay, I'm going to write here. Direction of the vector what we have to find out. Okay, that is C bar. So its direction is C cap is equal to what he said in the direction of A bar. Direction of A bar will be given by A cap. This is the direction of A bar. Okay, so A cap how much? We already found here. This is A cap. Okay, so directly I write here that is equals to 2I cap plus J cap plus 2K cap. What happened? 2K cap upon 3. Okay, this is what we got A cap. So C cap already I came to know. This is C cap. And mod B bar also we found. This is solution now what I am writing. Okay. Mod B bar also look at there in the first page. I think we got where here mod B bar. Mod B bar is equals to how much? It is 6. So I write here without finding out it again. I write here mod B bar is 6. Okay. That's it. You know the magnitude of C bar. You know the direction of C bar. Magnitude mod C bar. Direction C cap. So how to write a vector? We already discussed in the class a vector can be written as the multiplication of its magnitude and its unit vector. This is already given in the class. Okay. C bar equals to mod C bar times C cap. Mod C bar times C cap means mod C bar is 6. C cap is 2I cap plus J cap plus how much? 2K cap upon 3. This is C cap. So if you cancel there, you will get what? Here 3 ones are times cut, that is 2. So here 2 times we have to multiply to get the final answer. So final answer is 2 twos are 4, 4I cap plus that is a 2J cap plus 2 times 2 twos are 4, K cap upon 1. Upon 1 no need to write. So this is finally C bar. This is the way how to find the third vector whose magnitude is equal to one of the vectors direction in the direction of the second vector. Okay, understood this one, Anna? Do you have any doubt regarding this problem? You can express in your WhatsApp group. No doubt. Very good, very good. Understood. Okay, right. Okay, and I think you know how to find the directional cosines. Okay, no need to explain the directional cosines. Like cos alpha is equals to a bar by mod a, b by ax by mod ax. Got it. Okay, right. So ax by mod a bar, ay by mod a bar, az by mod a bar. Okay. So directional cosines, I think I gave this question. Show that the directional cosines of two vectors are same. Okay, you can find out. Okay, good. This is the way how to solve the other kind of questions. Okay. Then look at here. Suppose three vectors are given. I'm moving to another example now. Means doing few applications here. Right. So here three vectors are taken as the sides. How? In order. Whose sides? Equilateral triangle. So forming one equilateral triangle here. This is our equilateral triangle and each inner angle is 60 degrees. All of you know. Okay, it is an equilateral triangle. So what I am going to write here, these are three vectors, okay, like p bar, this is like q bar, and this is like r bar. Three vectors p, q, r. Okay, they are forming an equilateral triangle means indirectly we came to know their magnitudes are equal. Okay, so it forms, sorry, not it, the three vectors. The three vectors form an equilateral triangle. Okay, three vectors form equilateral triangle. That means what the information we found once you write there in the solution. So mod p bar, since they are forming equilateral triangle, all sides are equal. Sides means the lengths of three vectors are equal. So mod p bar equals to, I can write mod q bar, that equals to mod r bar. Okay, these are the three vectors. This is the information what we have found. Each, let it be some L. Say, we are assuming, say, let it be L. Right? Now again coming back to the question. Find the magnitude of one of the medians. Okay, one of the medians. Right? One of the medians means any one median if you take, observe that this will be one of the medians. Median joining the vertex and the midpoint of one of the sides. This is a median. So in basic mathematics, that is in the bridge course also I said, okay, it is the length of altitude. Length of altitude is equals to how much if the side length is L, okay, side length of median is nothing but height of the vertex from the base. Height of the vertex, I think all of you remembered what I gave previously, root 3 upon 2 times the side length. Okay. So length of medium, directly we are getting the answer without using any vectors concept here. If the side length is L under the assumption. Okay. So length of median is root 3 by times 2. L means I can write that is equals to root 3 upon 2 times what L is either mod P or mod Q or mod R. So this is the length of median. Okay. And in the same question, find the angle between the given vectors if they ask. Means in the question I am extending, also find the angle between the given vectors. Okay, angle between the given vectors means don't say 60 degrees, no, they are in order. If vectors are in order, then the angle between the two vectors is not theta. Angle between the two vectors is 180 minus theta. That's why in this triangle we have to say, is it 60 or 180? Sorry, 180 minus 60. 180 minus 60 means 120. Okay, am I right? Is it correct? If the angle between two vectors in order is 60 degrees, yeah, the angle between two vectors is not 60, it is 180 minus 60, that is equals to 1. Yes, yes. So we have to accept that here. Yeah. And second question answer, I'm moving to next page here. Shall I move to next page? Is it copied? Yes. So I'm moving to next page. Yes, sir, copy. Okay, right, good. So coming to here, also find the angle between the two vectors means we have to take them when they are originated from the same point. That's why here angle between the two vectors means they are looking like originated from this point. So angle between them is not 60 degrees, that is 180 minus 60 degrees. Yeah. So angle between them is 180 negative 60, that is equals to 120, whereas this angle is 60 degrees. Okay, we already discussed in the class. So in this next page, I am going to write angle between the vectors is equals to here 180 negative 60, that is equals to, I am going to write it as 120 degrees. Okay, that's it. This is one question here what we discussed. And here sometimes the addition of vectors is helpful in finding out the length of diagonals in a given polygon. Polygon means more than three sides. If you take, that is a polygon. Okay, three sides you can form a right angle triangle or equilateral triangle or isosceles triangle. One triangle you can form. Suppose if I form a hexagon like this with the six sides, one, two, better you take all the sides are equal, three, sorry, in the direction, yeah, and then four, okay, of same length, and then five, and then the sixth one. I formed a regular hexagon. This is actually called as regular hexagon. Regular, keep in mind, regular means they have same magnitude, like in equilateral triangle. Okay. Suppose these are the vectors A bar, B bar, C bar in the same way. Quickly if we write, they are like D followed by E followed by F. Okay. Regular hexagon. Okay. So in regular hexagon has what I say, regular hexagon has the sides of same length. Same length. I'm going to write as. Same length means again their magnitudes are equal. Like mod A bar is equals to, like in the same way continue without beating board. Here B bar. This is like mod C bar. This is like mod D bar. This is like mod E bar. And this is like mod F bar. All they have same magnitude. Let it be, say, in the same in the previous question, L. Then the vector method, I think, helpful to find out the lengths here. Suppose anyone asks you, find out the length here from where to where. Here we can easily find out. Okay. In the same way, find out the length here. What? This length. Here to there, you can find out. Find out the length from here to there. If anyone asks you, you can easily find out like this. Okay. How, sir? Simple. These are the two vectors taken in order. In order, that two, how many sides are there? 1, 2, 3, 4, 5, 6. 6 sides. 6 sides means total angle is 360 in a closure shape. And 6 sides are there. So divide with the number of sides, that is 6. So you are getting that is equals to 60 degrees. 60 is not the interior angle. The 60 degrees exterior angle, this one. What you are taking, this is 60 degrees. Means interior angle is equals to 120 degrees. 180 minus 60. Okay. So here already we know, if the angle between the two vectors is 120 degrees taken in order, the angle between the two vectors is not 120, that is 60. So we know between A and B, theta equals to 60 degrees to apply the parallelogram law of vectors. Okay. What will be the length of this pink line? Like if I give the names, say some P, Q, the points R, S, P, Q, R, S, T, and U. Now I am asking the length of PR. Okay. So you know that here what, all the sides are equal. Okay. Means here angle between the two vectors 60 degrees, you know, their magnitudes are equal. two vectors of equal magnitude make suppose an angle 60 degrees. The resultant of those two vectors is root 3 times to the magnitude of any one. Remember this one, Anna? All of you? This is a shortcut I think gave in Saturday's class. Okay. So directly I'm going to write the magnitude of PR bar is equals to root 3 using the shortcut root 3 by 2 times I write, sorry, that is root 3 only, times mod A bar. Okay, right, good. Mod A bar I took how much, Nana? L. So length of mod P bar equals to, I'm going to write here root 3 times L. Okay, this is the shortcut we discussed. Remember that shortcut on all of you? Theta equals to root 3 times 60 degrees. Then if the magnitudes are equal for two vectors, then the resultant is root 3 times 2f. Theta equals to 90 degrees. This is root 2 times f. If theta is equals to 120 degrees, what we derived that day? 120 degrees. Then that is equal to 1f. All of you remember this shortcut now? What I gave in the class? Yes, yes. So all of you remember theta equals to 60 root 2 root 3f like. Okay, right, good. So here using the shortcut, I wrote here this is root 3l. Okay, so what is the length of this pink line? That will be what? This is root 3l. Okay, then in the same way you can find out PS and PT also. PT is very easy. Why? Because same kind. These two vectors are in order. Okay, within an interior angle. All the interior angles in regular hexagon is 120 degrees. So again, these two are like A and B, making an angle 120 degrees in order. Means angle between them is 60 degrees. Then the resultant again is equals to root 3 times to the one of the vector E or F. E or F or B or C or D or A, anything is equals to L. Their magnitude is L. So directly I write here, this is root 3 times L. Okay, just you have to find out the magnitude of this one. What PS equals to how much? Okay, for that what I am going to do here, this is a line taken which is the magnitude of these two. Okay, right? So here in a parallelogram, once you observe, just briefly I am drawing here. Suppose these two sides are equal and it is a parallelogram, means all sides are equal, right? These two are taken in order and here all sides of length L, 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 L each. Okay, and I know the angle between these two is 120 degrees, like suppose what I am saying. This is 120 degrees. This is 120 degrees. Then resultant will come like this. And we say for two vectors of same magnitude, resultant always bisects the angle between the two. Bisects means the interior angle here, acute angle 120 means total angle 60 degrees here. 60 bisects 60 by 2, so it will be 30 degrees. Okay, if it is 30 degrees, you can say what will be the angle here. Okay, 120 plus 30, that is 150. 150 plus, if it is 30 degrees, we can say the angle is, total angle in the triangle is 180 degrees. That's why here what I am saying, it is 120 degrees. Okay, it is here 120 degrees. Okay, right? So it tries to bisect the angle here. Okay, so by considering the angle there, I think it is easy to find out what is resultant PS. That is, PR and RS are taken in order, Nana. Okay, are taken in order means this is just like associative law. A bar plus B bar, this is plus C bar. So you can find out the magnitude of this part. Okay, so magnitude of PS, I am leaving it as homework to you all. Try to solve it. Okay, find the magnitude of, here already I found which magnitude is root 3L again, that is a PT magnitude. PT bar has the magnitude equals to root 3 L. This is the magnitude of PT bar. So here just I am asking, leaving the question, PS bar, it has a magnitude how much, equals to how much. This is homework. Try at home and use your vectors concept. PS bar equals to how much. Okay, right. Try to find out. If you won't get in the next class, I will explain, no problem. Right? Good. Then we try to move to the next concept. Okay. What is the concept, sir? Suppose I am taking here one coordinate system. This is the coordinate system. xy coordinate system. I think you know how to represent the vectors in each quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, for the first quadrant, both are positive. The unit vectors are positive, like plus I cap plus j cap. In the second quadrant, x component, x unit vector is minus I cap, it is plus j cap. Third quadrant, I cap and j cap both are negative, minus and minus. And here in the fourth quadrant, x and y coordinates, if you check, x component is means x in the direction of x bar, the unit vector is plus, and then in the direction of y axis the unit vector is minus j cap. You know the representation in the four quadrants. Now what I am doing here, I am keeping three vectors, all the three are position vectors. Position vectors means taken from origin. Okay, how all are having equal magnitude, but taken like this. Same magnitude means its magnitude is say some f, its magnitude is also f, the magnitude of third one is also f. All the three have same length, same magnitude, but they are in different directions. Okay, but the thing is what he said, angle between any two vectors, if you check, like first one, second one, position vectors originated from the same point, angle is 120 degrees. And here the angle between these two is also exactly 120 degrees. Okay, angle between any two vectors is 120 degrees. Here also I am saying the angle is 120 degrees. Next, angle between the two vectors, sorry, up to here. Angle between the two vectors. This is also 120 degrees. Okay, this is what he has given there. Okay, for the three vectors, find the resultant. This is, you take it as one example. Of course, this is also an example. Okay, now the question is find the resultant of the given vectors. Okay, now if you check here, if I take another color, you can understand easily. Look at it. Third f is exactly along negative y-axis. So, of course, we can do in three ways, different ways, right? And the one most appropriate means you can understand very easily is resolving a vector into two components. That you can understand very easily. Okay. First, if I want to write F1, the force, which is in first quadrant, look at there how much angle it makes with x-axis. Okay, don't say 120 degrees, 120 with a negative y-axis. So with x-axis how much means? X to y the angle is 90 degrees, it is 90. So very easily you can say the angle over there. How much? 90 plus 30 is equals to 120, the total angle. That's why it should be 30 degrees. Okay. Already we discussed how to resolve a vector into two components. Look at along this red line x-axis. It is adjacent side for the given angle 30 degrees. Okay, adjacent side, how to write, sir? Adjacent side, A cos theta. We discussed in the class. So A cos theta, A is F, cos theta, that is cos 30. Cos 30 means root 3 over 2. So this will be equals to F root 3 over 2. Okay. And here look at the other component along y-axis. If it is F cos 30, that will be F sin 30, other component. Sin 30 is how much? 1 by 2. So F is equals to, that is equals to F times, you are getting sin 30 is 1 by 2. Okay. Why I resolved it into two components? Because he is asking resultant of the three vectors. Resultant means resultant R bar is, how many vectors are there? Three vectors. So resultant, how to write? In the form of addition. Okay. So in the form of addition, how to write? How to write? Like for three vectors, F1 bar plus F2 bar plus this is F3 bar. Okay. So we have to add the three vectors, F1 bar plus F2 bar plus F3 bar. Okay. For that I am writing the first vector F1, okay, whose magnitude is F, and here like F1 bar. Okay. Once you check, Nana, here what I am going to write, I have to move to next page. If you have any doubt, then I will explain. Otherwise, I will move to next page. Understood. Okay. So, shall I move to next page? Okay, then moving to next page here. Yes, come to here. How to write? Okay. First F1 bar, look at there. What are the components? Along x-axis, you got F root 3 upon 2. So this is F root 3 upon 2. Okay. Yeah, F root 3 upon 2. This is along x-axis number. So positive x-axis plus I cap. And look at the second component, that is f times 1 by 2, that is f by 2, f upon 2. Here I write the second component and it is along positive y-axis. So plus j cap I write. This is f1 bar Nana. F3 bar, it is very easy to say. You check there. F3 bar, that is exactly along negative y-axis. Negative y-axis, f magnitude, negative y-axis, so minus j cap. So f3 bar, I am going to write it like what? Minus f j cap. Its magnitude is f and it is in the direction of negative y-axis, minus j cap. Okay, just we have to write f2. Once again you check. Again, this is 90 degrees. If you check over 10, this is 90 degrees. Out of 120, it is 90, means remaining angle again it will be 30 degrees. If it is 30 degrees, again x component, by resolving like this, you will get f root 3 upon 2. Okay. And in the same way, after resolving, you will get y component here f upon 2. Same components you are getting. But it is in the second quadrant, so y component is positive, x component is negative. In second quadrant, minus x plus y. Okay, so f2 bar, I am going to write here f2 bar is equals to, in the same way what I am going to write, x component is negative, negative x-axis, f root 3 upon 2 I cap, but y component is positive plus y-axis, so I am going to write here f by 2 j cap. Okay, so f root 3 by 2 minus I cap along negative x-axis, f by 2 plus j cap along positive y-axis. Those two I wrote here. So what he is asking, find the resultant of the three given vectors. Resultant is what? Addition of two vectors. Two or more number of vectors. So that addition already I wrote here. Three vectors are taken. So f1 bar plus f2 bar plus f3 bar. So just what the deal here you have, adding the 3. That's it. Okay. So resultant just by addition you will get. Again, I'm not writing f1 bar plus f2 bar plus f3 bar. Already I wrote that in the previous page. So directly adding. While adding, once you check I components here, 2 only there. That 2, one is positive, other is negative. Same magnitude. So shall I cancel them now? They get cancelled here. One is positive, other is negative. Same magnitude, same I cap. Okay, over. 3 j cap components are there, means x component is actually I got 0 by cancelling these two. So 0 I cap plus y components, if you check there, f by 2 j cap. If I take common from all the three, okay, or else simply f j cap if I take common. Why? Because f by 2 is not there in the third one. So I am taking f j cap common. F j cap common, that is 1 by 2 here in the first one. 1 by 2. In the second one also I am getting 1 by 2. F j cap is taken common. Plus, so plus 1 by 2. And in third one, look at there, if I take fj cap common, here you have minus 1. So once again you check here the magnitude. Half plus half is 1, 1 negative 1, 1 minus 1, 0. So you are getting, this is 0 I cap. Even that also 0 times f, 0 into f is 0 only. So plus 0 j cap. Both the components are 0 means its magnitude is also 0. Like root of ax square plus ay square. Both are 0. So root of what we write 0 square plus 0 square, that you will get 0 again. So its magnitude is equals to 0. Okay. So sometimes we will get the magnitudes equal to 0. That's why now I am specifically defining here, which is called as the vector having the magnitude 0. Okay. The vector, now I am writing the vector, okay, having the magnitude 0, wo, the vector having the magnitude wo, that is 0, is called, we are giving some name to it, is called null vector. It is called as null vector. Okay, this is the name of the vector having the magnitude 0. Okay, it is a null vector. So next time when you get the null vector, easily identify, oh, null vector, it has the magnitude 0. Okay, whose magnitude equals to 0. If magnitude is 0, we won't put any arrow mark. That's why there is no specific direction for it. Okay, so in any exam, if they ask what is the direction of null vector? Null vector its magnitude 0. Magnitude 0 means we can't draw a straight line with the arrow mark. We can't put arrow mark. So it has no specific direction. That's why we write here it has no specific direction. Sorry. No specific direction here. Okay, this is a null vector. Then you may ask, actually, what is the use of null vector, sir? Null vector means magnitude 0. So, when you come to our physics, suppose the resultant of many forces acting on a body. Generally, force gives what? Motion to a body. Okay, the body at rest will move, comes into motion by the application of force. The body in motion will comes to rest by the application of force. So when a car is at rest, if you apply a force, then the car comes into motion. So force is required. Okay. In the same way, car is in motion. You want to bring it to rest. We have to apply the brakes. Means opposing force you are applying. So anywhere to change the state of body from rest to motion or motion to rest, we require a physical quantity called as force. Okay. If that force is 0, F is equals to 0. Okay. Means magnitude is 0. Then the Newton's laws will come. Okay. What Newton's first law says, when a body is at rest, will continue its state of rest, and the body moving with a constant velocity continues to move with the same velocity without changing. means the state will not be changed. Okay, so the body at rest will be at rest. At rest will be at rest means such type of position is called as equilibrium position. So if Fr equals to 0, we say then in case of forces, a body at rest will be at rest means is in equilibrium. Okay, so when you come to numericals anywhere, if you see this word equilibrium by the application of number of vectors, okay, from this concept you have to understand one point. What? In equilibrium, okay, Sar said in equilibrium resultant force is equals to 0. Oh, resultant of many vectors is 0. That's why in vectors chapter, by the application of means when many vectors are there and the point from which they are originated is in equilibrium, means like this. If I say this is one vector originating from here, this is a second vector originated from here, and it is a third vector originated from here, just like what we have done in the previous question. Exactly, look at that. We took all the three vectors in coordinate system in the same manner. Okay. Then I'm taking instead of F this time, this is vectors chapter. So I'm taking it as P bar and Q bar and this is R bar. Okay, three vectors are taken here. And I'm taking look at all the three vectors are originated from the same point. Means this is the point some A or O, some point O. Okay. So I say if P bar resultant, I am calculating. Resultant is addition. So P bar plus Q bar. Third vector is also there. So plus R bar. This is addition of the given vectors. Three vectors are given. So addition of three vectors. P bar plus Q bar plus R bar. Okay. Is equal to 0. You can say when you say P bar plus Q bar plus R bar equals to 0. If I give the condition in the question. What? If the point O from which they are originated, okay, point O is in equilibrium. Here I am using the word equilibrium. Okay. So if the point O is in equilibrium, directly you can say in a problem, O is in equilibrium, right? From which they are originated. So directly we can say P bar plus Q bar plus R bar. Even many number of vectors are given. P bar plus Q bar plus R bar plus PQR, S bar, T bar, U bar, V bar, W bar, like all sum of all vectors is equals to 0 if the condition is satisfied. O is in equilibrium. So the above concept we are going to use in our vectors. Okay. So this is one important model, equilibrium condition, right? That equilibrium condition, how to use in numericals. In next class, we will discuss. Already I gave an example. This is a simple example. So later on, we will try to find out. Okay. So understood all the points, Nana? Shall I wind up the class? Or any doubts in the pages? Understood. Okay, right. Good. So I'm going to wind up the class, and I'm going to stop the class. Okay. If you have any doubts in the lesson, it is there already in YouTube. So you can cross check once again. Okay. In the middle. Okay, Nana. Bye, everyone. I'm going to stop it here.